Welcome to myprojectbazaar.com. Now we can going to discuss about the product GI based control scheme for single stage grid interface GSCCS for power quality improvement. Now we can going to discuss about the abstract of a product. First we can see about the generalized integrator. The generalized integrator to improve our solar energy conversion systems, to improve our real and reactive powers of entire distribution system. So these are some abnormal conditions of our microgrid. We can improve our stabilized and normal power. We can getting that even basing on using for solar panel. In control scheme for providing the unified power factor capacity operations and loading balancing and filter migration to operate our reactive power compensations. So another thing we can see for algorithm process for second order generalized integrator algorithm to control blocks of our voltage source converter in solar blocks and dynamic performance of entire system. We can improve our this generalized integrator algorithm to test the scheme of this performance is parameterized research to improve the our operating conditions, such as we can improve our operating conditions for utility power factor conditions and load balancing and harmonic distortions and reactive power compensation. We can improve that, and the quality of power improvement enhancement to entire our grid, also improve our normal voltage. We can improve our fuzzy phase log for loop to improve our multiple of conditions. We can apply that our entire system will be purely for balanced, and we can improve our voltage stabilization also. Next we can going to discuss about the flow diagram of our product. First we can going to discuss about the solar panels. The solar panels are connecting the number of series cells in solar cell arrays. We can using for 72 cells are in the solar panels connected in series. So the solar panel is connected for some conventional process. We using that is a maximum power point tracking algorithm and using the boost converter. This is one of the complete blocks of this block. So we can generating for solar for generating power of DC power, pure DC power. We can DC to DC boost converter. We can improve our boostable level of solar panels, so we can getting the maximum power of solar panel. Next we can passing to the DC to AC converter. This is main block of this entire flow diagram. The another, if we can see the intermediate section of improved genetic algorithm. This is some logic control which is using for some formulation derived for improved generalized integrator. We can using that these sections. So this is on sections we can getting to switching pulse of DC to AC converter. So this is a main part of the DC to AC converter for load balancing and harmonic distortions and lot of things in the power factor also improve that. So this block we can improve our entire things of solar panels, and another thing load and ripple factor something everything we can control that this block. So we can generalize and improve my integrator. We can efficient to develop and power delivered to the DC to AC converter and control that the switching process. This line is entirely passed to the AC grid. This is not for AC grid. This is for weak grid. Because of this low power consumed the grid, this is using that some normal non-linear load and ripple factor. Using that non-linear load we can using for some fluctuation. We can observe that and consume the some power. We can getting the solar panel. Non-linear load but non-linear load for using that some consumer side also, and ripple filter we can using for that some harmonic distortion. We can reduce the ripple filter, so we can improve our linear power integrator to store the AC grid. The AC grid is nothing but we can store the energy and utilize the energy. So we can consumer side we can given the power. In case we can getting the power also consumer whatever we can using that this type of block diagrams. Next we can going to discuss about the running procedure of our product. The proposed system implementation done in MATLAB version 2013A. First to open the MATLAB file window and create the new model file, and the corresponding elements are using the simulating model library. So corresponding scope are entered in the our entire blocks of the modeling. Next we can going to discuss about the modeling of the blocks. So this is our entire modeling of the block. This is for grid and non-linear load and ripple filters and solar. These are improvise generalized integrator and the scope values will corresponding to getting that to using for from two functions. Next we are going to discuss about the results. This is for our source voltage. Source voltage means our grid side voltage. How much we can store our grid? Nearly it's stored for 4 to 500 nearly using to store that this grid voltage. Next we can see the grid current. This is our grid current ISA. This is an ISA, ISB and ISC. So different grid currents. Some distortions will be occur, that is using for our non-linear load. This is for our reactive power and real power. This is our reactive power. This is our real power of source. Using for is on very high power wave. Using the x-axis zoom and create that this model. Reactive power obviously purely zero. So and our entire power system is on getting for real power. So our power is on improved that this type of scope. Next we can see about it. This is for our generalized improved generalized in integrator block. This is an main part of this entire system. So we can find out the different analysis purpose. This is on amplitude, terminal voltage, and this is estimation in phase unit templates and a lot of things we can find out that this entire subsystem blocks. And this is an evaluation of PV feeding component. This is for evaluation active power losses component. And this is a determination of I net total net current. This is total load current. This is determination of load current. So this can find out that this is on one of the another main block. This is on sampling and holding circuit and using the zero cross direction blocks. This is on main. This is also one of the main part of the block. So we can find out this entire system compared to the some mathematical derivations to solve this block. Where we can lot of the subsystems we can using that these particular sections. This is also some reference current to this something give to the input and getting the output of these sections. We can see that some derivation we can calculate that. This is on our switching pulse. Similar that we can I will explain that flow diagram also. This on switching pulses are very important to getting to our entire system as an improved our solar voltage. So we can just open and you see the x-axis zoom. X-axis zoom, click that and just click and move on and move to. So these are our switching pulse. We can getting the better switching pulses. We can getting that. So this one switch 1, switch 2, and switch 3, and switch 4, switch 5, and switch 6. We can use 6 switches for voltage source converter. In case in first switch is on, second switch on is off. Similar that we can using the different duty cycles also. If it is first switch is totally one time 0.28 time period it will totally on, it will suddenly is totally off. So it will a random inversion process. Switch 1 is similar to inversely to switch 2, similar that 3 and 4 and 5 and 6. Next move on to solar panel. This is for our solar panel results. This is for our DC to DC boost converter triggering pulses and saturation regions. Some perfectly getting the our triggering pulses and saturation regions. And VDC. This is our VDC for solar panel boost converter levels. Because of we can getting the voltage of nearly 96 voltage we can getting, but we can improve our power of voltage of 750 VDC we can getting that. So we can lot of difference in this wave to improve our boost converter.